Okay, pretty sure this is recording. I don't know if it was recording and I just turned it off, or if it was off and it just started recording. So we will find out. For my in-class students, I actually have a practice exam printed up, and I have another pack of paper, which will act as your key. I don't know if y'all can see it. Yeah. Anyways, this will be the actual key. This looks more like what you're used to seeing on the homework. It's literally just because I accidentally printed two different ones. If you could please, on problem 1, there's a typo. I wonder if I can use a pencil. I'd rather do that since I don't have much room, you know. If you see here, I've got 1/5 W plus 1 equals 6/5 W. And on the one I typed up, I have 1/5. I did X, y'all. I was not kidding when I tell you I don't like if I don't have to use another variable, I'm using X. Plus 1 and then equals 1/5 X. It's actually 6/5. So for continuity and to be able to check your question, I'd go ahead and change that to a 6. And you definitely can't see very well what I did, but y'all should have that in front of you. Okay, so I want y'all to just notice that the answers usually in the question, if you're looking at something and you're not really sure how to go about solving it, I try to specify maybe like how you should do it or what you should do or what you're looking for at least, right? So this will actually act as my key. Oh no, this isn't your exact test. I was like, oh, I'm gonna answer the exact test and then grade y'all on it. No, this is the practice. Okay, so this is the key though for the practice. So by reading the directions, you should exactly know what you're going to do. This says solve the equation using the addition property of equality. Okay, so I know that because it's an equation, what I need to do is solve for my X variable. I've got an X variable on the left-hand side, and I've got an X variable on the right-hand side. Now, even though this says addition property of equality, remember, we could always add a negative, right? So even though it says that, what we can do here, don't we need to move one of them, right? Get all the X's on one side. So if I look at the right-hand side, if I moved that one, I would be doing a negative 6/5X, and I'd be doing it to both sides. This is actually going to be larger than this side, so I don't want to move that one. I want to move this one. And I get it. I know it says property of addition, but we can add like a negative number. You can do like 2 plus -5. I'm adding a negative, but it's still in this, for some reason in this book, it's still property of addition, right? I like to say subtraction, but I'm adding a negative is what they're saying. If I move my 1/5X, I do the inverse, right? That's a positive 1/5X. The way you move a positive number is to do a negative 1/5X. You use, I hope y'all are just listening and not trying to read this because it's hard to see. You use the exact same numerical value, right? 1/5 with the exact same variable and stuff you're looking at. The only difference is the sign. It was positive, now it's negative. Whatever you do to one side, you have to do to the other, right? So I'm also going to do a negative 1/5X on the right-hand side. Do you see how on the left-hand side, it's like, okay, I did that for a reason, right? I wanted to move it. I wanted it to go away. So using the exact same value with the different sign, even though it's a fraction, y'all, exact same value, different sign. It could be the number 2. I'd get rid of 2 by doing a -2, right? This just happens to be 1/5. To get rid of it, you do a negative 1/5. Same thing. On the left-hand side, y'all, what do I have left? Just that 1? Equals. I know everyone loves fractions. Totally being facetious. Everyone hates fractions. I love them. But I'm weird. Do you see how, even though, yeah, I get it, it is a fraction problem, and it's like I thought we moved on, I thought we were in chapter 10. Do you notice their denominators? They're the exact same. These are the easy fractions. These aren't the mess with it, okay, now do it. This is just straightforward, do it. I've got 6, I'm gonna pull it here though, just so you can see 6/5. And then that says that's a subtraction sign, right? So because my denominator is the same, it stays the same. It's not even because my denominator is the same, it stays the same. It's more my denominators better be the same because it needs to stay the same. Now what, y'all, if you do math here, 6 minus 1, what's that? 5. And then we keep the variable, keep the exponent. What is 5 divided by 5? 1. And then we have our x. So you could write the number 1 and x, but I just do x. And just to like show y'all this, what we just now did, I was going to give you an example with like 2x and then minus 1x, but it's not really the same because it's not really like a fractional example. So hopefully that makes sense. I can just straightforward combine those because my denominators are the same on the exam. And I would hope also on my math lab exam, the denominators will be the same. I'm not testing you on fractions. I'm testing you on the little equation, okay? So 1 equals x. If you look at your key that I accidentally printed, yes, 1 equals x, okay? Okay, so let's do problem 2, which says solve the equation below. It'd be hard writing with these little bitty numbers. Do y'all agree that the 6 touching the parentheses, that's pretty important, right? Like that's step number 1. Okay, can't really solve anything because I've got a variable inside of these parentheses. The only way you're going to technically get it out of the parenthesis is to distribute the 6 in, or if there's nothing going on around it, you could just rewrite it. But here there is something going on around it. So I multiply those. 6 times 4x. 6 times 4 is 24. Those are both positive. Signs are the same. So my 24 is positive. I need to notice here though, that 4 had an x attached to it. So when I do this multiplication, don't forget your variable, okay? And then what do I do with the 6 and the negative 1? Multiply it, okay? Very important. You look at your numbers and we get 6 times 1 is 6. Y'all, signs are different. And in multiplication, if you got a positive and a negative, what you end up getting for your product is negative. I always just say signs are different, so it's negative, right? And then don't forget this right here. Just bring down that plus 6 equal, we've got a negative 96. Like I haven't done anything to those. Now, do you see how if you accidentally don't multiply this 6 and 1, your next step isn't going to be written like this? What happens to these, y'all? If you have $6 in your bank and you spend $6, you got none dollars. Yeah, I mean, they went away. They're called additive inverses. What I want you to notice, what we did here, that was using an additive inverse because it made it go away, made it go to 0, right? Look right here. Same exact numbers, different values. In a way, what they do, you're not supposed to really say this, but they cancel each other. They just go away. They became 0. That and that canceled each other. More technically put, their inverses, they go to 0, right? But yeah, you notice the exact same number with different signs on the same side of an equation, just make them go away. If you didn't do this multiplication correct, you wouldn't have seen this. And then your answer is going to be all wrong just because of one little mess up, right? So what do I have now, y'all? Let's kind of rewrite this. 24x equals a negative 96. I was doing the math in my head. I need to solve for my x, right? What do I do now? What's happening to my x? Is it being multiplied by 24, right? This is what I want. That's what's going on around it. So I want it to be like this, but it's being multiplied by something. The only way to get rid of or cancel multiplication is division. Again, supposed to say, you know, the inverse of multiplication is division. Y'all, you're making it go away, right? So you do the opposite. Whatever you do to one side, you have to do to the other. Left-hand side, 24 divided by 24. Use your calculator. You're going to get 1 every time, right? But you just need to know that I did that for a reason. I divided by 24 because I wanted that 24 to go away. I wanted it to no longer be multiplying my x. Y'all, I'm going to kind of come right here, okay? So on the left-hand side, technically what happens, because it's division, is they became 1. So what we get is 1x, but I don't write the 1. I just write x equals. Now this is what I'm looking at right here. 96 divided by 24 is 4. Those signs are different. So it's a -4. Yep. I was seeing something in a different light just now, if I could explain it, y'all. Look, I always question sometimes because when things come easy to me, sometimes it's hard to explain them. So I always want to try to explain them well. Do you know how when we got to here and I was like, oh, it's being multiplied by 24. You know what I mean? Like you have to do the opposite. You got to get rid of it. And we divided by 24. Whatever you do to one side, you have to do to the other, right? I was sitting there thinking how someone might get confused by that statement because do you see how I canceled these? So it was almost like, you know, I had a -6 and I added a 6. Or it's like I had a +6 and I subtracted a 6. And it's like, why did I only do that here and not over here, right? And it's because those two values were already written there. They just happened to cancel each other. I actually wrote the divide by 24 myself. But you'd be surprised the math that I'll see on exams sometimes. And so it's like I'm always trying to find certain ways to like pick out things that I hope make sense. I wrote those 3 terms down and 2 just happened to cancel each other. It just happened. That's just math, right? $6 in your bank, you spent 6, became 0. Here, all I had mathematically was 24 times x. That's it. I actually am the one who did the division. So since I did something to one side, I had to do something to the other, okay? So let's do problem 3. So still the same as far as solving an equation, but this talks about the different solutions that we did. I think it was like Friday. I want to say it was Friday or Wednesday. It's been a while. So we'll follow the same steps we've always followed to solve an equation. The only difference is, and we should have this in our notes, y'all, if it's a solution set, didn't we just have like x equal something, right? X equals a number. That means it was a solution set. If we have 0 equals 0, that answer was all real numbers, right? And then do you remember how if we solved the equation all the way down, and after doing all of the math, we got something like 3 equals 7. That's not true, right? Like, so that's saying that there's not a solution. And that's what that little symbol means. So this is x equals a number. This is 0 equals 0. This is just a weird contradiction. Okay. So does anybody remember? Do you remember? Whenever we got like halfway through and I was like, oh, it gets kind of confusing. But if you remember this, you can jump straight into the answer. I'll do a little asterisk next to it. And if someone does remember, you can call it out. Okay, let's solve it. On the left-hand side, super important, 5 touching a parenthesis. That has to multiply everything. So literally, I'm going to do 5. I feel like you can't see anything on the thing I'm recording. I'm going to do 5 times what's inside of that parenthesis, which is a 2x and a -8. First one is 5 times 2x. Do y'all agree that's 10x? Okay, very good. Now let's multiply that 5 in the other term, right? So I do 5 times 8, and I get 40. Those signs are different, so it's a -40, right? So technically, like I'm done with that left-hand side. There's nothing I can do. I can't add those together. Like they're not even the same. I got my equal sign. Excuse me. 10, touch in parentheses, distributed in. Goodness gracious. Okay. 10 times x That's just 10x, right? And then I distribute, I multiply it to the other term, right? And I get 10 times 4, that's 40. Those signs are different, so it's negative. Anybody see anything here? I'll solve the whole thing. Yes, thank you, Trey. I'll solve the whole thing. But you go further than this, it gets pretty confusing because you're like, whoa, hold on. My x's just completely went away. And well, my right side just, you get down to 0 equals 0. But in the process, you don't trust your math. Like, it looks really weird. So the thing I tried to show you was if you're solving an equation and it's asking for solution sets, if you're solving an equation and you get left-hand side equals right-hand side completely 100%, that means this is one of those confusing problems that you're going to eventually get down to 0 equals 0, which, and I don't care if you box it, circle it, highlight it, but it's a B. When you get the, and this is all in your notes, y'all, when you get 0 equals 0 as an answer, your solution set is all real numbers. That's literally telling me no matter what number my x is, it's going to be true on each side, okay? So let me actually work it so everybody can see it. This is something I want to stand out. So, okay, I need to solve for my x. That means I need to move one of my x's. Usually I'm looking at which one's bigger. They're the same number, so I guess it doesn't matter. I could do 10x here. I got to do the opposite, right? It's positive, I do negative. I do the same thing. Okay, now let me look. 10 minus 10. Okay, so those just went away. I had $10 in my bank. I spent $10. I got none dollars, right? The x's, everything goes away. So, bye. Bring down, I got a negative 40 equals, okay, yeah, that's right. I wanted that to go away. And then I got a negative 40. Okay, I'm very confused. I don't really know what to do. It's a negative 40, so I guess I need to add it to both sides, and that went away and that went away. Do you see what I'm saying? You do it enough times, it's not a big deal. You study other things and then you try to do this. I don't want you to question yourself. Y'all, I got to something that was the exact same. If that happens, that will always happen. So if you can recognize it, jump straight to your answer. If not, solve it, but just don't get stuck and stay on a problem for too long and then mess up something else, because, you know, that's going to end up being an all real numbers answer. Okay, I got one more minute before I let y'all go. And I think I could solve this in a minute, for sure. For sure. And I want to kind of solve it too, because that ends that little equation chunk, right? So 11x minus 3 times x minus 6 equal 8x plus 3. So I just need an equation. I just need to solve it the way I know how to solve it, and then I just kind of see where I go with it, right? The 3, y'all, that's distributed. And you have to make sure you pay attention. That's a negative 3. So when I do my multiplication, you have to make sure that you know that's a negative 3. Let me go ahead and write my 11x, because I'm not doing anything to it, right? Right here. I'm just going to go ahead and write this. This is what I'm doing my math on, but don't leave that off. I literally almost did. So bring that down. Now look right here. Negative 3 times x. Well, that's a negative 3x. Okay, now let me do the other multiplication. Negative 3 and negative 6. Well, 3 times 6 is 18, right? And then those signs are positive. Why'd I say that? Those signs are the same. They're the same exact sign. They're both negative. Those signs are the same. Therefore, it's positive. And then look, haven't done anything. Bring it down. Now, let me look again. Okay, hold on. I got 2 x's over here, right? Because those are the same variable, same exponent, I can combine them. I can do math there. I can do 11 minus 3, which is what? 8, 9, 10, 11? That's 8. Don't forget your variable. Plus 18 equals 8x plus 3. Okay, I need to get my x's together. It's positive, so I make it negative. That goes away. 18 equals, wow, that goes away. 3. Does now ever, or will it ever, be true that 18 equals 3? Yeah, no, never. That is a contradiction. That does not exist. That is not true. If you get something that you know for a fact is not true, it says DEF. The other one must have said ABC. Your solution is the little line with the line through it. That's saying no solution. F is saying my solution is that there is not a solution, because that's not true. Okay, does that make sense? So when we come back on Friday, we'll do, and like y'all have got videos for everything. Though even the problem we messed up, I did it perfect. Like y'all watch them. When we come back on Friday, we'll do all the other problems. I think it's like through 14, 5 through 14. Yes. So if y'all have questions, make sure y'all let me know, and definitely watch the video.